In this video, we're going to be looking at 3 examples to show what concentration is and to kind of get an idea of what quantity per volume really means. So in our first example, we are asked to calculate the concentration in ppm of chlorine ions found in drinking water if 795 grams of chlorine ions are added to 256 million grams of water. So again, just to remind ourselves, ppm, that stands for parts per million. So that's just saying how many parts of a given solute are within a million of a solvent or something along those lines, because you want to find concentration. So we know that concentration, or C, equals quantity per volume. So how much is there of something within a certain amount of space? And then because we're looking for a value in parts per million, we're going to multiply quantity per volume times 10 to the power of 6 parts per million. And just as an aside, we're doing that because 10 to the power of 6 is equivalent to 10 million. So that will give us the amount that we want. So C equals quantity over volume times 10 to the power of 6 parts per million equals 795 grams divided by 256 million grams times 10 to the power of 6 parts per million equals 3.1 parts per million. Therefore, the concentration of chlorine ions in the water is 3.1 parts per million. All right, now we're going to look at another example where we're calculating concentration as a percent volume. So percent V divided by V just means what percentage of a given volume is made up of a particular quantity. So in this question, we are asked to calculate the concentration as a percent volume of a solution that has 5 mils of pure acetic acid per 100 milliliters of solution. So for this, we can again use C equals quantity over volume, but this time we're going to multiply it by 100% rather than times 10 to the 6 ppm, because we want to have a value in a percentage. So the quantity, because we're trying to calculate the concentration of acetic acid in the solution, the quantity here is 5 milliliters. And the volume of the whole solution is 100 milliliters times 100%. So that is going to equal 5% volume. So the percent volume of this solution is 5%. All right, and then we just finish that up with a quick therefore statement. Therefore, the concentration of the solution is 2%, right? Because we always want to go back to quantity over volume. All right, we're going to look at one final example in this video to understand the idea of what concentration really is. So here, a solution contains 38.2 grams of potassium bromide in 78 milliliters of water. What is its concentration in grams per 100 milliliters of water? So again, I'll show you two ways that we can do this. So the first is our traditional C equals quantity over volume. So we're looking for the concentration of potassium bromide in grams per 100 milliliters of water. That's what we want to get at the end. So we know that the quantity is 38.2 grams, and we know that that's dissolved in 78 milliliters of water. If you put that into your calculator, then you're going to get a final answer of 0.4897 grams per milliliter. So once you have this value, then we can calculate the concentration in grams per 100 milliliters. We can do a couple of different strategies. First one would just be taking that concentration that's circled in red, multiplying it by 100 mils divided by 100 mils. The point of doing this is so that in the end we're going to get a value in grams per 100 milliliters. So you'll know that that amount of milliliters, those will cancel out. And then when you multiply this value times 100, then divided by 100, we are going to get 48.97 grams per 100 milliliters. So if we had 0.4897 grams in 1 milliliter, then we're naturally going to have 100 times that amount in 100 milliliters. So that would be one way we can solve for it. We also can, and this is a skill that might help you when we get ahead to solubility, we can simply set up an equivalent proportion. So if we know that the concentration equals 38.2 grams per 78 milliliters, the concentration in grams per 100 milliliters has to be the same. We are just writing it in different terms. So that means it's going to be equal to X over 100 milliliters. And then I can just rewrite it once again. Multiplying both sides by 100 milliliters so that we get X on its own. And then when we multiply all of those things together, type that into your calculator, the 38.2 divided by 78 times 100, you would get that X equals 48.97 grams. And then, as you will probably remember, that was the same. So there were two different strategies that we could use to tackle this last problem. But again, we always want to go back to the idea that concentration up here is a quantity per volume. It's quantity over volume.